starting at the top of the page, they introduce the term law of sines. The first thing they point out here is the term oblique triangle. So up until this point, we've used trig functions to solve right triangles. Solving a triangle means giving me all the angles and all the sides, right? And so if I give you a triangle and I give you a couple of pieces of information, if they want you to solve it, they want you to give me all the information, all 3 angle measures, all 3 side measures. And we've done that with right triangles. But now they want us to do it with oblique triangles, or triangles that are not right triangles. And so this is the introduction to law of sines. The law of sines says that you have any triangle. It does not have to be a right triangle. And they have labeled it angle A is across from side A, angle B is across from side B, and angle C is across from side C. For any triangle, these sides and angles will be set up in ratios. The sine of A over A will equal the sine of B over B, which equals the sine of C over C. This is the law of sines. Let's look at the first example. Solve this triangle. Round side lengths to the nearest tenth, the angle measures to the nearest degree. So we're going to look and we see that we have angle B and we have side B. You must have at least one angle and its side opposite to use the law of sines. All right? So we are going to start with that side. We're going to say sine of B, 103, over side B, 20, should equal, and the next one that I have here is A. I have the degree for A, so that should equal sine of 35 over A, which I do not know. I do not know that one. And so you're just going to use really cross multiplication here. Just like any ratio, solving any ratio, right? We're going to say then that A times the sine of 103 should equal 20 times the sine of 35. How do I solve that? How do I solve for A?
You have to divide sine.
Right, I have to divide here. And I've got it. So, and this can go straight into your calculator. You can literally do it all. Your calculator may open parentheses, but you need to say 20 times the sine. It may pop open parentheses here. That's fine. Sine of 35. Close those parentheses if it does. Divided by the sine of 103. And then you can hit your enter. And you will get side A. Rounded to the nearest tenth. Rounded to the nearest tenth, you should get 11.8. 11.8. Now, we do not have angle C. However, I have 2 out of 3 angles in a triangle. How do I solve for angle C? They all add up to 180. So I'm going to say 180 minus 103 plus 35. 180 minus 103 plus 35, you'll get 42 degrees there. And so I'm going to do the same exact thing with side C that I did with side A. But because I rounded side A, I'm going to go all the way back to my one that they gave me so that you're not rounding in the process. So I'm going to go back and I'm going to say sine of B, 103, over side B, 20, equals sine of C, 42, over side C. And you're going to do the same process, right? You're going to end up that C is going to equal 20 times the sine of 42 divided by the sine of 103. And you're going to get 13.7. Now here's what your answer should look like when you do this solving of a triangle. You should have the measure of angle A, angle B, and angle C. And you should give me all of those. 35, 103, and 42. And then you should have side A, side B, and side C. And you should give me all of those. 11.8, 20, and 13.7. So your answer should look like this for me. If you're solving a triangle, I need all 3 angles and all 3 sides. An Earth orbiting satellite is passing between the Oak Ridge Laboratory in Tennessee and the Langley Research Center in Virginia, which are 446 miles apart. If the angle of elevation to the satellite from Oak Ridge and Langley's are 58 and 72 respectively, how far is the satellite from each station? All right, so they will not always give you a picture. So pay attention to the wording here. It says that they are 446 miles apart. So you want to make sure you have a point for Oak Ridge and a point for Langley and how far apart they are. Angle of elevation, that means from this observance center or this laboratory and up to the satellite. That's your angle of elevation. That's 58 degrees, 72 respectively, just means in the same order as what they listed, Oak Ridge, Langley. So from Oak Ridge would be 58, from Langley would be 72. All right, they labeled this A, B, and C. And then we have A, we have B, and we have C, side C. How far is the satellite from each station? So I do not have my third angle. I don't have an angle and a side across from the angle. However, I have this side and two angles, so I can solve for this third angle. How? I have these two angles. How do I solve for C? Yeah, so I'm going to say 180 minus 58 plus 72. So this right here is 50 degrees. 50 degrees, okay? And so now I actually have what I need to solve for the other two sides. So the sine of 50 over 446 equals the sine of 58 over A. Don't forget, though, that A will tell you from Langley. Your cross multiplication there will give you approximately, rounded to 2 decimal places, 493.74, and I think they rounded up to 494 miles. All right, so it's going to be, from this one, it's going to be 494 miles. All right, same thing for the other one, sine of 50 over 446 equals the sine of 72 over B. Cross multiplication there will give you 553.72, and they rounded to 554. So this one's 554 miles. All right, same. I'm going to talk a little bit about ambiguous cases. So way back in geometry, we would have talked about whether something can form a triangle. And remember, in order for it to form a triangle, any two sides must be added together and longer than a third side for any triangle. You have to be able to add up two of the sides of the triangle and it be longer than one of the third sides. And so with ambiguous cases, there are times when you have this problem right here where your third side's not long enough, and so it actually can't happen. And then you have a perfect right triangle. That's when they equal. A squared plus B squared equals C squared. But then you have a case like these last two here. For these last two, this is 2 inches. I have a 30 degree, and they did 1 inch. That's great. But then what happens when they bring it in closer? These two have a 2 inch and a 1 inch and a 30. And it actually can be two different triangles, right? And this is where you have to think about on your unit circle signs that produce the same, or different angles that produce the same sign. So my sign here would be my sign here should be of a 30 should be 1/2, right? That's how sine of 30 always works. But you'll notice that I was able to draw two different triangles to do that. Think about your unit circle. Well, pi over 6 gives you 1/2 of a sine, but so does 5 pi over 6, right? That gives you a positive 1/2 sine. 5 pi over 6 is an obtuse angle, right? It's bigger than 90 degrees. So a 30-degree angle will give you the same sine as a 150-degree angle. Those two will give you the same exact sine. So remember we learned reference angles, right? This is where reference angles come into play. And so so this first thing says find two triangles for which A is 43 degrees, side A is 25, and side B is 28. All right? So here's what they've done. We have some random triangle here, right? Draw a triangle. So we have some triangle. All they gave us was information about one of the angle measures and two of the side lengths. All right, so we're just going to draw this triangle here. We have A, B, C. We know that A is 43 degrees, that side A is 25. We do not know B, but we know side B is 28. We're going to set up law of sines here. Sine of A, 43, over side A should equal sine of B, which we don't know, over side B. All right, cross multiplication here. 28 times sine of 43 divided by 25 should equal sine of B. What trig function do I use when I'm solving for the angle? The inverse, right? The inverse. And so this means that the inverse sine of all this good stuff here, 28 times the sine of 43 divided by 25 should be my angle. So put that into your calculator. What do you get? All right, so you should get 49.8. If you round to the nearest degree, 50 degrees. All right, so 50 degrees if you round there, rounding. So about 50 degrees, all right? So let's think about this. It could be 50 degrees. That's absolutely a possibility. I'm going to look at my unit circle, all right? Looking at my unit circle, 50 degrees. 50 degrees is going to fall somewhere in my first quadrant, right? First quadrant. 45 is right down the middle, so 50 degrees is probably going to be a little bit above 45. We'll just say it's there. That's probably closer to 60, but close enough. So let's say this is 50 degrees, all right? That will give me a sine of all this good stuff in here. But if I were to do the same thing over here, right? Let's assume that I drew it perfectly the same and that this is also 50 degrees. That will give me the same sine, the exact same sine, right? Does that make sense? So what is that angle measure? If I start way over here and go all the way to there, what is that angle measure and how do I find it? 180 minus 50. So that means a 130-degree angle should give me the same sine as a 50-degree angle, should it not? So try it. Does it? If you do the sine of 130 and the sine of 50 in your calculator, what do you get?
7 points.
Yeah, you get the exact same, 0.7660444, right? You get the same exact sine. And so what they're saying is this could mean my triangle where I have this 50-degree angle, or I could have a triangle where I have a 130-degree angle. So two different cases can yield the same results when you have something like this, because your calculator is always going to use from negative pi over 2 to pi over 2 for sine. It's only going to give you those angles. But the truth is you have reference angles in the second quadrant that would yield the same sign. It's not going to give you both of them. It's just going to give you first quadrant for positive, fourth quadrant for negative, okay? But you have a mirroring sign in second quadrant. Remember your unit circle, you can mirror it, right? Sine would mirror first and second quadrant. Cosine would mirror first and fourth quadrant, right? And so it's always going to do that. It's always going to give you just that range when it could be two different cases. And that's what ambiguous cases mean here, that it could give you more than one. So law of sines is when you have an angle and the side opposite the angle. Law of cosines is necessary when you don't have that. Like when you have three sides and no angles. or you have just one angle, but you don't have the side opposite that angle. This is law of cosines. They list it 3 different times, but it's literally the same formula, just done 3 different ways. It's just using a different side. Basically, what you'll notice is the side that's on the outsides matches the angle on the other end, all right? And then this is just the other 2 sides squared minus 2 times the other 2 sides. So these are just the same formula, they just picked a different side to start with, all right? So the law of cosine said I'm going to take a side, square it, that equals b squared plus c squared minus 2bc cosine of a. And this is what happens when you have cosine, you have a, but you don't have the side opposite. And you cannot back into it using like 180 minus the other 2 angles. All right, so let's look at the example. World example. When a hockey player attempts a shot, he is 20 feet from the left post of the goal and 24 feet from the right post as shown. If a regulation hockey goal is 6 feet wide, what is the player's shot angle to the nearest degree? So they're saying he is 20 feet away from the left, 24 from the right. This width is 6 feet. What is this angle? We cannot use law of sines. We actually don't have any angles here. So anytime you're solving for an angle, that is the one that's going to be the cosine. All right, so if I'm solving for this one, I'm going to use A. And so I'm going to use the a squared equals b squared plus c squared minus 2bc cosine of a. All right, and I'm just going to plug all of that in, what I know here. So a squared, well, that's this side right here, opposite a angle, 6 squared, equals b squared, that's the 24, plus c squared, that's the 20, minus 2 times 24 times 20 cosine of a, which I don't know. Now I'm solving for the angle, so I'm going to actually have to solve back, all right, just like algebra here. To get the cosine of a by itself, I need to do some things. I need to get this by itself, so I need to subtract these 2, right, from both sides. So I'm going to have 6 squared minus 24 squared minus 20 squared, right? That's going to take care of that, yes. And I also need to divide by this negative 2 times BC, right? Divide both sides by that. So I divide here, negative 2 times 24 times 20. That will equal the cosine of a, but I'm solving for the angle A. So what do I have to do? Which trig function? Not cosine. I'm solving for the angle. What do I use? The inverse. So basically, you're taking the inverse of both sides, and you'll get, so inverse, I have to take the inverse here. And that will give me just A. You can do all of this in your calculator, but pay attention, okay? In your calculator, you're going to have to do the cosine, -1. It will automatically open a parentheses. You need a second set of parentheses there, okay? Open another set. You can do 6 squared minus 24 squared minus 20 squared. Close that parentheses. Then hit your division. Open another set of parentheses. -2 times 24 times 20. Close parentheses again, and then it will do it for you. So when you round here, you should get 11.7 degrees, which means this, he had an 11.7 degree range here for a shot. They want me to solve this triangle. So when they want you to solve a triangle, you are going to look for the path of least resistance. Law of cosines is more difficult than law of sines. Just in the process, there's more room for error. But if I were to be given this triangle, I would have to start with the law of cosines because I have 2 sides, right, but the two sides that I have do not correspond to angles that I have. The one angle that I have, I don't have the corresponding side. If this happens, I have to use law of cosines, right? And I'll get this right here. Once I have this, I have an angle and the side opposite. I can move from law of cosines to law of sines. So for this one, I would use law of cosines to solve for side C, right? And I would have this. Then once I had that, I would move to law of sines. And I would solve for one of the other sides. So then I could say, well, sine of C over C equals sine of A over A, because I have A. And then I could solve for angle A, right? And then for angle, so for this would give me angle A. Well, then to solve for angle B, I would just use my knowledge of 180 minus angle A plus angle C, right? And that would give me angle B. And then to solve, I have actually solved the entire triangle, right, at that point. So I would start with law of cosines, because that's where I have to start. And that would give me my third side. I would move to law of sines to give me one of my angles. And then I would just use my knowledge of all triangles have 180 degrees to get my third angle. And so that would give me side C, angle A, and angle B, and I will have solved that triangle. So just because you start with law of cosines doesn't mean you're going to have to use it the whole time. You're just going to have to use whatever's the easiest. Just because I use law of sines to get one of my angles doesn't mean I would use it again. I would just use what I know about 180 at that point. And so solving a triangle is going to always be what's the easiest thing to do with what I have. All right, so we, up until this point, would have said, if I said, what's the area of a triangle, you would say 1/2 base times height. 1/2 base times height. But that is assuming you know your base and your height of your triangle, right? For a right triangle, that's easy. If you know your legs, then you know your height and base of your triangle. But this is another way to do it when you don't have that information. This is called Shermans Formula. Shermans Formula. The area equals the square root of S times S minus A times S minus B times S minus C. S is the sum of your sides divided by 2. All right? So it's not hard to do. It's just you've got to remember it. So let's just look at it, how we would do this particular one. Find the area of this triangle. The first thing we have to find out is that S. All right? So we're going to take our 3 sides. 51 plus 38 plus 45, and we are going to divide it by 2, multiply by 1/2. That will give us 67. So that is our S. And then we literally just plug it in. So then the area is going to equal the square root of that number, 67, times that number minus my first side, times that number minus my second side, times that number minus my third side. And that is the area of my triangle. They round it to the whole number, 830 square inches. But the hardest part is remembering the formula. Add up your sides, divide by 2, that's your S. Then you're going to take the square root of that number times each side subtracted from that number. And that will give you the area. So if you have only your 3 sides, you're going to have to use Shermans formula, all right? But if you happen to have one of your angles, in fact, it's the setup which you would use law of cosines for. Like if you have your angle here and the sides either on the opposite sides that make up that angle, right, the legs of that angle, then you can use sine equals side area. And this area is just 1/2 your two sides that you have times the sine of the angle in between them. All right? Simpler formula, definitely. So for this one, I would say 1/2. My area is going to equal 1/2 my 10 times my 7 times the sine of the angle in between it, 108. And that's going to give me the area of this particular triangle here. And they rounded to 1 decimal place. 33.3 is my area. Much simpler equation.